Let's take a question. A point traversed half a circle of radius 160 centimeters during a time interval t equal to 10 seconds. Calculate the following quantities averaged over time: the mean velocity v, the modulus of the mean velocity vector v, the modulus of the mean vector of the total acceleration if the point moved with a constant tangential acceleration. Now let's come to the first part, A. What it basically says is the mean velocity. So the mean velocity we know will be equal to total distance traveled by time taken. Distance traveled is half a circle, so it's pi r, pi into r, divided by total time taken. You can calculate this, whatever it is. This will be the mean velocity in appropriate units. You can convert this into meters, and then you'll get the mean velocity in meters per second. So this will be the first part. Now the second part, because this calculation is pretty straightforward. It's pretty straightforward, right? The total distance divided by the total time taken. Part B, the modulus of the mean velocity vector. Now what does this mean? What is the meaning of mean velocity vector? Now the mean velocity vector basically means that you're talking about a vector which is basically equal to delta r by t. So what it basically means is that if you, for a certain duration, you want to find out the modulus of the mean velocity vector, what you generally have to find out is the change in the r vector and in how much time that change has taken place. And then once you know that, you have to divide change in r vector by the time. And here you are required to find out the modulus of this vector. You will find out the mean velocity vector and then find out the modulus of the vector. Modulus of the vector, as you may know, is equal to the magnitude of the vector. Right? So if a vector has a certain magnitude and a direction, so the modulus means the magnitude of that vector. So in this case, you have a semicircle, right? Like this. Okay. Initially, the body has a velocity like this, or the particle is like this, vertically upwards. This is a little bit slanted. It's vertically upwards. Finally, the velocity is vertically downwards. Initially, if you take from this point, the r vector is like this. Finally, the r vector is like this. Initial ri is like this. If you consider this is the point of origin, the final rf vector will be like this. If you take, this is the point of origin. So rf is this, ri is this, right? So what is the change in r? Rf vector minus ri vector minus ri vector. Right? Now what is Rf minus Ri? We are seeing here that Rf and Ri are in the opposite directions, right? So because of that, Rf minus Ri effectively will be equal to Rf plus Ri. In terms of magnitude, we can say that Rf minus Ri will have a magnitude which is equal to the magnitude of Rf plus the magnitude of Ri. Why? Because these vectors are in the opposite directions, right? So the total displacement or the total change in R will be equal to Rf plus Ri in terms of the magnitude. So the total this will be equal to total this vector. This will be the resultant. I am calling this as the resultant. This is the initial vector. This is the final position vector. We have to find out RF, final position vector, minus initial position vector, which will be this, right? So this minus this will be equal to this plus minus this, right? So RF plus RI. What is minus RI? If this is RI vector, minus RI will be the opposite of this vector. So just invert this vector in laterally by, this vector is pointing towards here. So we can consider minus Ri to be a vector which is pointing towards here like this. This will be our minus Ri. This will be RF. So RF plus minus Ri will be equal to total this vector. So this is the total vector. This is the total. This basically represents the total change in the R vector, and the magnitude of this will be equal to the magnitude of RF plus the magnitude of Ri, which is equal to 2R, right? This is the central point. Magnitude of RF plus magnitude of Ri is equal to 2R, 2 into radius. So the modulus of the mean velocity vector will be equal to the modulus of this, which will be equal to 2R, and time taken we know is equal to 10 seconds. So this the modulus will be equal to R by tau. Tau is 10, R we know 160 centimeters. We can calculate the modulus of the mean velocity vector. So we come to point C. Modulus of the mean vector of the total acceleration if the point moved with a constant tangential acceleration. Now there is something that we need to understand before we actually approach this part. Let us draw a VT graph for a certain particle with constant acceleration. This is V, this is T. We know that the VT graph for a particle moving with constant acceleration will be a straight line. Let us suppose we talk about a time interval, say T1, and say another time interval T2. Suppose the velocity at T1 is equal to V1, and velocity at T2 is equal to V2. Now we all know that acceleration is equal to dV by dt. So V is equal to integral A dt. Right? Also, at the same time, we also know that V is equal to dx by dt or ds by dt. So x is equal to integral V dt. Okay. So in fact, this equation is more relevant for this case actually. So now we are talking about this particle which is moving with a constant acceleration. Now suppose we want to find out the distance traveled by this particle between T1 and T2. That will be the total distance within this curve. Right? This total distance will be the addition of this rectangle plus this triangle. There is this rectangle and there is this triangle. So the area of this rectangle plus the area of this triangle, which will be the total area under this curve. Okay. Now let us calculate it. Let us say area of the rectangle is say A1. So A1 will be equal to this into this. How much is this? T2 minus T1. And how much is this? V1. This is A1, which is the area of this triangle. Now let us come to this triangle. This is a rectangle, sorry. This is a rectangle. The area of this rectangle is equal to this multiplied by this. This is equal to T2 minus T1. This is equal to V1. So the area of this rectangle will be equal to T2 minus T1 into V1. Area of this right angle triangle will be equal to half into base into height. Say the area of the right angle triangle, suppose if we call it A2, will be half into base, T2 minus T1 into height. What is the height? V2 minus V1. V2 minus V1. So the total area is A1 plus A2. This plus this. Now take T2 minus T1 common. V1 plus V2 by 2 minus V1 by 2, which will be equal to T2 minus T1 is the delta T. This will be equal to V1 plus V2 by 2. The total area, as we know, is the total distance traveled by the particle. So what I am trying to say out here is that the total distance traveled by the particle in case the acceleration is constant is equal to the initial velocity plus the final velocity by 2 multiplied by the time duration. Okay, now we've seen this. Now let us come back to this part of the question. The modulus of the mean vector of the total acceleration if the point moved with a constant tangential acceleration. Now say that this is the trajectory of the particle and it moves with a constant tangential acceleration. You can think of this particular path as a straight line, because it's quite similar to a straight line path in the sense that the velocity in terms of direction changes. The direction of the velocity changes continuously, but its magnitude, in fact, magnitude also changes, but the acceleration along the tangent is constant. So it's quite similar to the case of a particle which moves with on a straight line with a constant acceleration, with a constant linear acceleration, with a certain initial velocity and with a certain final velocity. And if you consider a straight line with a length equal to this total length, so there will be a lot of similarity between that motion and this motion, right? Now what we have to find out here, mean vector of the total acceleration. So when you say mean vector, again, mean, there are two words in it. One is the mean and the other is the vector. So whenever you say mean, it automatically means that, see, you have to find out, just have to do a final minus initial. And the word vector means final vector minus initial vector. So this is the meaning of these two words, mean vector. Mean means final minus initial divided by time, and vector means final vector minus initial vector, right? So in this case, the initial vector is this, initial velocity vector. Now we know that the total acceleration, mean acceleration, if you want to find out, will be equal to total change in velocity vector divided by total time duration, right? V mean is equal to total change in R divided by time duration. Similarly, A mean will be equal to total change of the velocity vector divided by time. Now what is the total change in the velocity vector? The final velocity vector minus initial velocity vector. Initial velocity vector is like this. The final velocity vector is like this. They are in the opposite directions. So at the end, if you do a final minus initial, final is like this, vertically downwards. Initial is like this, vertically upwards. This is, say, you can say this is VF, this is VI. So final minus initial, since they are in the opposite direction, will be equal to, in terms of magnitude, that will be equal to the magnitude of VF plus the magnitude of VI. Right? Why? Because they are in the opposite direction. So if you do a VF minus VI, you are basically doing a VF plus minus VI. Now what is minus VI? This is VI. Minus VI is the opposite of this vector. What is the opposite of this vector? This. This is minus VI. So VF plus minus VI will be equal to this vector. Right? Because basically what you are trying to do is VF plus minus VI. So you are trying to add VF with minus VI vector. And since you are trying to add VF with minus VI vector, what you get is this. And the magnitude of this will be equal to the magnitude of VF plus the magnitude of VI. Right? So VF in terms of magnitude of VF plus VI is the total change in velocity divided by time taken, which we know is equal to this much. Now VF plus VI, this is what we want to find out, the magnitude of the AM. I am calling this AM, modulus of the mean vector of the total acceleration, is this, will be given by this. I have explained why it is like this, right? Because total change in velocity will be equal to VF plus VI. VF is the final velocity, VI is the initial velocity. Why? Because VF and VI are in opposite directions, and time, tau, is the total time taken. Now we know from this that VF plus VI by 2 multiplied by time taken, tau, is equal to pi r. Why? Because this is a case of constant acceleration. Right? Total distance traveled is pi r. Initial is VI, final is VF. So VF, if we apply this particular thing, what do we get? VF plus VI divided by 2 multiplied by total time that the particle takes to reach from here to here, that will give you the total distance, which we know is equal to pi r. Right? So VF plus VI we know is equal to pi r. So VF plus VI is equal to 2 pi r by tau, and this will be equal to, put this value of VF here, we will get VF plus VI by tau is equal to tau 2 pi r by tau square. Right? After that you can just substitute the values and you will get the answer.